spent a decade in quantitative finance, really building machine learning and deep learning models to trade financial futures, stocks, and really kind of the same space where we're anomaly detecting here at Buzz Solution. That's a subset of this kind of huge, broad umbrella of what can you use AI for.
So AI doesn't replace the team. AI is now on the team.
Yeah, or just elevates the team, really. The team gets to do their job.
Welcome to the maiden voyage of the Buzz and Beyond podcast. I'm Stephen Watt, the marketing manager for Buzz Solutions. And today's guest is Nick Libertini. He's the machine learning team leader for Buzz. And our topic's going to be leading transformation. Thanks for joining us today, Nick.
Yeah, thanks, Stephen. Excited to be here.
So you've been involved in AI and machine learning since the beginning. So you've got a degree in mechanical engineering and economics, and then a master's in finance. So you're kind of a dual threat, technical and business.
Yeah, like you said, I've been doing, machine learning and AI stuff for the better part of 17 years now. And yeah, I did get a degree in finance after I got my engineering degree. I was super passionate and excited about the financial markets and spent a decade in quantitative finance, really building machine learning and deep learning models to trade financial futures, stocks. Again, the technology was a lot newer then. We weren't using as big models, as complex models as we were today, but definitely been doing this for a while now.
Yeah. Okay. So you started with time series data and looking for results that would help make money, pretty much, right?
Yeah. Most of what we were doing was analyzing the recent history of stocks and financial futures, looking back over the last few weeks and months and trying to identify or teach the model to find patterns in the data that would be reproducible trades that we would take. And so a lot of what we were doing was, if the stocks go down over a few days, what's the probability they're going to be up the next day? Or if this basket of stocks deviates from this basket, is there a convergence trade or something like that? So we were building models to exploit those and putting real dollars at risk, really.
And then in 2021, it looks like you moved to the MIT, is it the Lincoln Laboratory?
Yeah, I did a decade in quantitative finance and had a lot of fun. But at that point in time, I saw an opportunity to kind of pivot into the DoD or intelligence space. Lincoln Lab is a partnership between the Department of Defense and MIT, and they do a lot of research for defense initiatives. And so I got an opportunity to go work on a team there. We were building complex computer vision algorithms to try and solve some national security problems.
Okay. We won't go into details on these, of course, because they're confidential, but I did hear computer vision. So this is when you started applying machine learning and AI to imagery.
Yeah, it was a bit of a career shift, switching from financial markets into this space. But honestly, there was a lot of carryover. I mean, a lot of the foundations of building models for financial markets, wanting to make sure that what you're building on historical data will work in production, carried over here as well. We were building models and we want to make sure that what we were building in the lab would carry out into the field and work for the warfighter.
Okay. So after the Lincoln Lab, then you joined Buzz Solutions, and now you're working on imagery for critical infrastructure.
Yeah. It was kind of a natural transition there as far as leading a team at Lincoln Lab to now leading this fantastic team here at Buzz Solutions. We're solving very challenging problems like we were at Lincoln Lab, using a lot of the same tools as far as imagery captured from drones and that type of stuff. And really kind of the same space where we're anomaly detecting here at Buzz Solution. That's a subset of this kind of huge, broad umbrella of what can you use AI for. One of the things you can use is training models to find anomalies in these image data sets. And you really want to make sure that when you're training those and they're working on your kind of training data set, that they'll also be applicable and find stuff in the field when you actually run your models out and try and put them into practice.
So across your career, across finance and the national security and critical infrastructure, what are some of the key lessons you've learned about applying machine learning to these data sets?
Yeah, I think one of the biggest through lines that's kind of carried through my entire career is you really, when you're training a model, whether it's to trade stocks or to predict anomalies, you really have to have trust that when you're done training it, that it's learned something useful that will be applicable to data it's never seen during training. It's very easy to fool yourself when you're building, kind of black box artificial intelligence models that, hey, this model has 90% accurate, it's performing really good on my training set, but that's not the data that your model is going to be used on. It's actually going to be used on data it's likely never seen before. And so you have to build up a set of robust evaluation criteria to say, look, we've trained this model. It's really good at detecting this type of anomaly on power line equipment. And it actually works on new imagery that we've never seen before. And so building that strong validation gives you confidence that the model will work in the field or in production when you're going to apply it to new imagery.
Okay. Now with critical infrastructure, it seems to me there's a bit of a difference because what you're trying to do with critical infrastructure is not necessarily be 100% precise, but you're trying not to miss something important, right? So how does that affect the model development?
Yeah, yeah, it's a great point. I think that there's a lot of different areas that you can optimize for a model. One of those things that you can do, like you mentioned, is optimize the model's ability to find anomalies. In that case, you're trying to find those needles in the haystack. And it's more important that you acknowledge that, hey, maybe there's only 5 or 6 of these anomalies out in my data of thousands of images. I want to make sure I catch as many of those, even if I have some false detections. Hey, this looks like what I'm looking for, but it's not quite. And so there you're optimizing for recall. And you really have to coach the models to try and think and look for those anomalies in all the different ways they can manifest among the huge pile of nominal data that you're training your data or your models on. And that's completely usually inverse of what you're doing in, say, finance or quantitative training, where a lot of the focus is on precision. You have an opportunity to trade any minute, any day, any hour. So there's a lot of opportunity to put capital at risk, but you want to make sure that when you do deploy capital and your model predicts, hey, take this trade, that it's right more often than not, that it has high precision, that you're putting your capital at risk in good situations. So they're kind of inverse of each other. And the way you coach the models to be receptive to either high precision situations or high recall situations is really baked into how the machine learning team trains their models and how they validate their models as well.
Ah, very interesting. There's a lot of buzz about using synthetic data to train models. What are your thoughts on the use of synthetic data?
Yeah, I think, in this era of generative AI, I mean, we all see it. We're exposed to it on social media. We see it come across our feed. It's so impressive what the models can do these days. They can generate very realistic scenes. They can augment scenes and take a summer image and turn it into winter. They can really transform how we train these models because we may not have all those different angles and views captured from the drone. Maybe we have one view of the power line, but now we want another view. Maybe we have one season or one lighting condition. So I think they're extremely powerful, and I think people should consider using them. I think one caution is it really goes back to this through line is how do you trust that your models learn something that will generalize in production? And in that situation, if you're using synthetic data, what we found is it should be restricted to your training data set. And the reason is there might be subtle patterns that we can't perceive, but the data generator has put in these fake images. And they're kind of like a watermark or a fingerprint that these other classifier detector models will pick up on. I mean, these models, even though they're black box, even though they seem really complex, what they're really doing is looking for patterns. And so if the generator puts in some pattern that's really noise, but it's kind of a fingerprint that, hey, I'm a synthetic image, the other classifier is going to pick up on that potentially and make it very easy to hack the problem. So if you use that data in your validation set, you might fool yourself saying, wow, we added a bunch of synthetic images. Our model performance is going way, way up. We're looking really good. So instead, what you need to do is restrict that only to training. And in that situation, it has to, learn generalizable patterns because those synthetic watermarks don't show up in your validation data set. And so I think it's very powerful, this synthetic data, these generative models. I think you should be using them, but you have to be very cautious not to let them leak into what you're using to evaluate the models and making that final deployment decision.
What about, for some of our customers out there, let's say they're in the grid modernization team or the asset management team, and they're trying to modernize their inspection processes with AI-enabled software like Buzz Solutions. What bits of advice would you give these folks at the utilities?
Yeah, I think one of the biggest lever points that I see for this type of technology is just the force multiplication aspect of it. In this day and age, we have great capability to capture high quality imagery of our assets. We're almost overwhelmed with that amount of data. These types of tools, they're really not, in my opinion, at a point where they're going to replace subject matter experts that are looking at these images, have deep knowledge about the failure modes, the asset types, but we have to acknowledge that these subject matter experts are few and far between, and they simply cannot look at the hundreds, if not millions, of images that we're capturing. And so the best place to use these is when you marry them with subject matter experts. You deploy these models to kind of sift through all of that data, highlight kind of a high recall situation where they scoop as many potential anomalies, as potential defects. These are the types of things that are high value for then the human to review. And now the human can apply their subject matter expertise to the highest value images, confirm what the model is seeing, and then all the other nominal images can be safely ignored, and we can get the best of both worlds there. So that would be my advice: is look for those areas where the subject matter experts are overwhelmed by data. There's a lot of data. Apply the models there to reduce the amount of imagery that your people are looking at. You get a lot of value that way.
Okay, very good. That's interesting. So AI doesn't replace the team. AI is now on the team.
Yeah, or just elevates the team, really. The team gets to do their job and they get to apply their skills to the highest value items in that data set. And it really makes their job count even more because you've sifted through all the other images that they shouldn't be wasting their time on.
Now, what about, a lot of the bigger utilities, they have their own analytics team, right? And they want to build their own models. What advice do you have to those teams about make versus buy? When should they build and when should they use something existing?
I think that there's a lot of smart people working in utilities. I've seen and I've talked to a lot of the analytics teams, and there's a lot of great people out there. And I have no doubt that any one of those teams can build models that are high quality, high caliber. I think the challenge that we see is then taking that model and moving it to production and applying it day in and day out, making sure that it's accessible across the organization, standardized, and then as data drifts, retraining the model, updating the model, keeping the model available. Those are the challenges that we find internal teams sometimes struggle with because there's a whole world of software and world of ML ops that goes along with just deploying and serving your model. So I think that sometimes that's the biggest case of, should we do this in house or should we have an out of the box solution that kind of handles that for us? Nonetheless, I still think it's important for internal team to continue to experiment and benchmark with their models. Because if you have something that's better than what you can get out there, that's really valuable. You have to hang on to that, even if you're leveraging another solution to help deploy or bring that solution to scale. Or just translate, hey, we have a really good model. We know it works with these features. Can you help us replicate and scale that? That would be the type of conversation that I would be looking to have.
Very good. So really there's like a whole life cycle to a model. It sounds like that they should be thinking about.
Yeah, absolutely. I think a lot of people kind of think, okay, well, you train the model, it's good, we're done. And I think that training the model at some point might be the easy part. And it's everything that comes after that. It's putting the model into production, serving it day in and day out. there's a whole host of activities, a lot of software, a lot of thought has to go into those pipelines. So the model is a key piece. It's a centerpiece here, but it's not the only piece.
Yeah. So, I mean, it's funny. I mean, looking back, you made a really good decision in about 15 years ago to go into this area of AI and ML. What's your favorite thing about working in this space?
I really like that it kind of combines this idea of science and engineering with subject matter experts across a bunch of different fields that I never really expected. If you go into mechanical engineering, is where I got my undergrad degree, there's interesting problems to solve. But right now, I'm usually not the subject matter experts in the problems that I'm helping solve, whether it was in national security or, here on the utility side. I get to work with a lot of people that know their craft really well and build models that scale that craft to thousands, millions of impact points, which that brings a lot of, value to them. And it makes me very satisfied that, wow, we can do this with the technology we have today. So that's what I really enjoy about, the field of AI.
Great, great stuff, Nick. I think we're out of time, but I really appreciate you joining us today and sharing all your insights. Fantastic stuff. And thanks to the audience for joining Buzz and Beyond.
Yeah. Thanks, Stephen.